Hello and welcome back to Precalculus 1. We have section 2.6 on rational functions. And rational function is the function which contains the fraction where you divide two polynomials. So we're going to take a look at the properties. We're going to take a look of those functions and also the way to graph those functions. They are needed for calculus, so we need to make sure that we really know how to deal with this one. As usual, please sound your questions in the chat, and we'll go from there. So rational function. Let's go immediately. Rational function is going to be division of two polynomials. So p of x divided by q of x, both of those polynomials. And the representative function of this is going to be the function 1 over x. So that would be probably the simplest, that is the simplest rational function we can talk about. We memorize the graph. The other ones we have to compute. This one we memorize. And now we take a look at all of the specs of this particular function. Number one, obviously, domain. Domain is going to be given as negative infinity to 0, union 0 to infinity. Domain is interrupted at 0 because x equals 0 has to be excluded from the list of values that you can compute in the function. We got that by setting denominator to 0. Range is also negative infinity to 0, union 0 to infinity. This function also doesn't have the value at y equals 0, right? Number 3, there are no x or y intercepts. Now, once we start shifting this function using what we learned in 1.6, we are going to create. So we are going to do all of these things soon. And finally, we have something that is called asymptotes. And in this case, we have a vertical asymptote at x equals 0, and the horizontal asymptote at y equals 0. Now we have to talk about asymptotes. There's going to be a whole talk about that, so don't panic yet. We are going to write down exactly what these things are, and then you will learn them. So I just wanted to put all of these most important things about our cheapest and easiest rational function, 1 over x. I just wanted to put that all in one spot. And now we are going to discuss what asymptotes are and how to find them. Rational function is probably the first place where you introduce these asymptotes, and then we move on to trig. 4 out of 6 trig functions will have them, and then obviously beyond that, asymptotes are used a lot later on, and they are also used a lot in sciences. We are going to take a look eventually in chapter 3.5. We're going to take a look at logistics growth, which will have horizontal asymptote, and we can model the coronavirus situation using logistics. It's modeled using logistics graphs. So I will explain, and you will understand how to read those once we get to chapter 3. But let's have a talk about asymptotes. So vertical asymptote. All right, so vertical asymptote is a vertical line at x equals c, where x minus c is a factor of denominator. So just to give a couple of ideas. Now there will be much better definition of this in calculus. Right now we just say we get a vertical asymptote by setting the denominator equal to 0. So in our case, if we had f of x equal 1 over x, which was the easiest case, well, then we just say x equal to 0, and there it is, right? That's the vertical asymptote. Vertical asymptote at x equal to 0. Another example, let's say f of x is equal to 8 divided by x plus 3. Well, in this case, x plus 3 equal to 0. Take away 3 on both sides. We get that the vertical asymptote is at x equals negative 3. And you can graph that vertical asymptote because it's a vertical line, right? You will go out to 1, 2, negative 3, and you will draw a vertical line that would be the barrier for the function to follow. So vertical asymptote is really a value that you compute when you set denominator equal to 0, and technically what it shows you is it shows you what x values you are not allowed to plug in, and the vertical asymptote into the function, right? And the vertical asymptote is also at the same time, right, showing you what values you need to kick out of the domain of the function, right? So let's say these are all separate examples. Let's say we have f of x is equal to 6 divided by x squared plus 4x plus 5. Right? In this case, you are going to have x squared plus 4x plus 5 equal to 0. And we're going to factor it to x plus 4x plus 1. No, lies. I have this backwards, right? Because I would need a 5 over here and 4 over here, so it factors nicely. Okay, let's switch this. I'm switching the problem so it factors nicely. There we go. So x plus 4, x plus 1, nice. And now x equals negative 4 and x equals negative 1. So in this case, we have two vertical asymptotes. Two vertical asymptotes, and so both of these are VAs, and immediately domain of the function is negative infinity to -4, union -4 to -1, union -1 to positive infinity. We are kicking out those two locations when vertical asymptotes are, because our function cannot be computed at those values. If you plug in a -1 in original problem, right, if you try to compute f of -1, you will get, in the calculator, you will get error. You will get undefined, because you are getting 6 divided by 0, right? Same thing for -4, right? Undefined. That's better. Undefined. It's undefined because in both cases you have 6 divided by 0, and that's not allowed. We cannot divide by 0. So vertical asymptote is a vertical line that goes through the value which produces 0 in denominator. And so in that case, we are going to easily compute vertical asymptotes when we set denominator equal to 0, and at the same time, hey, it gives us where the interruptions in the domain are. So they follow each other really well. Now you do have to be careful, though. You have to be careful, because if you are able to cancel a factor, then you do not have a vertical asymptote in that particular spot. So now that will be much better understood in calculus. Right now we just know we can cancel, and then we deal with a simpler problem. So let's say you have f of x equals to x squared minus 25. Sorry, that's going to be in denominator. X squared minus 25 is in denominator, and in the numerator we can have x squared plus 6x plus 5. So if you want to just set denominator equal to 0, well, you have to be careful, because the factor of x plus 5 will cancel. You see, if I factor both of these, in the numerator I will have x plus 5, x plus 1, because together that creates the numerator. And in the denominator I have x plus 5, x minus 5. So now these two cancel. So technically your problem is x plus 1, x minus 5, and the only vertical asymptote is at x equals 5. X equals -5 is not an asymptote. So the graph over here would be it would only have an asymptote at 5, and at -5, let me just see which way it goes. So -5, what's happening at -4? Negative divided by negative is positive. So at -5, you would have an open circle of some kind, like this. So the function might look something like this. It goes through the open circle there, and then follows like this. So these asymptotes are also guidelines on how to actually, this one will cross x-axis and go this way. It's fine. We'll figure those things out later when we do graphing. So it's important to know that if you can cancel, let me write that in blood over here. If we can cancel, then no VA vertical asymptote, right? No VA at that point. So that's why x minus 5, x equals minus 5, is not a vertical asymptote. So that's the story of vertical asymptotes for now. Obviously much more when you hit calculus 1 in chapter 2. Right now we just say vertical asymptote is a vertical line, right? And one more important thing, function cannot cross vertical asymptote ever. Let's write that here. So f of x cannot cross VAs. You can have multiple vertical asymptotes. Eventually you will learn that, let's say, tangent function has infinitely many vertical asymptotes. Our problems are going to have 1 or 2, maybe on a good day 3. But you can also have mathematical functions with infinitely many. And then we also have mathematical functions that have no vertical asymptotes, like x squared, right, which is a parabola. That one does not have a vertical asymptote. Technically, any polynomial doesn't have a vertical asymptote. None of them, right? So we'll learn other functions that have vertical asymptotes later, right? You will learn logarithmic function. That's in chapter 3. And you will also learn a whole bunch of trigonometric functions in Precalc 2 that will also have not one, but infinitely many vertical asymptotes. But that's when we get there. Cool. The next story is the story of horizontal asymptotes. Now, horizontal asymptote is a horizontal line at y equals L, and we have 3 cases. So obtained by, and here we go. Case 1. Your function f of x is polynomial p of x divided by polynomial q of x. Actually, you know what? Let's do this first. So that's your rational function, and these two are polynomials. Now, polynomials your polynomials will have leading term, and leading coefficient and the degree. So P is the degree of P of x, and Q is the degree of Q of x. So these are our 2 cases. So what do I do now? Case 1. Case 1 is P larger than Q. No horizontal asymptote. So if the degree of the exponent, right, the leading leading exponent is, or leading term, sorry, leading term, if the degree of the leading term is higher in the numerator than denominator, then there is no horizontal asymptote. Case 2. P is the same as Q. In that case, we will have ax to the p divided by bx to the q. L will be a over b. So it will be a quotient of leading coefficients. And finally, case 3, P less than Q, our horizontal asymptote at y equals 0. So that's 3 cases. 3 cases. So if I go back to the example we had earlier, where we said that x squared plus 6x plus 5 divided by x squared minus 25, we look at these, right, leading term. In this case, p equals 1. In this case, q equals 1. Those are our exponents. Sorry, p and q equal 2 each. Exponents 2. That means that L that we're looking for is 1 divided by 1, which is 1. So what you are looking at, actually, you know what? Let me write it this here. X squared divided by x squared. So your A is 1, your B is 1, your P is 2, your Q is 2. L is supposed to be A over B if P equals Q. Because P equals Q, because they're both 2, then we have asymptote. So horizontal asymptote at y equals to 1, because 1 divided by 1 is 1. Okay, so the next example would be, let's say f of x equals 3x squared plus 6 divided by x cubed plus x minus 12, whatever. All right, we are looking at leading terms only. So we have 3x squared divided by x cubed. Well, p equals 2, q equals 3. P smaller than q means what? P smaller than q means horizontal asymptote at 0. That's a case 3. So horizontal asymptote, abbreviation HA, is at y equals 0. It's a case 3. There's nothing to calculate here. You have to memorize 3 cases. You have to memorize 3 situations. So the case over here that we had the same P and Q. If they are the same, then you take the ratio of front coefficients. Example had both of them to be 1. So it was kind of lame. 1 divided by 1 is 1. Now, we don't have to look at front coefficients at all, because P is not equal to Q. And because P is not equal to Q, we can just immediately take a look at the case 3, right? Another one, let's say you have x squared plus x minus 3 divided by x plus 6. Well, in this case, p larger than q, and that means no horizontal asymptote. So anytime you have a higher degree in the numerator, there is no asymptote. If degrees are the same, you will divide front coefficients. And if the higher exponent is in the denominator, you are going to immediately assign a horizontal asymptote of 0. Now, more about this in Calc 1 when you introduce limits and you start calculating stuff. Right now, we want to know where the horizontal asymptotes are so we can have guidance to draw our functions. So now let's take a look at both of these at work. Say I have to graph f of x equals 1 over x. Well, we already know that there is a vertical asymptote at x equals 0. And now we also learned that horizontal asymptote is at y equals 0 because the degree in the numerator, 1 is equal to x to the 0, right? And in the denominator is x to the first power. So you have bigger denominator in the bigger exponent in denominator. Therefore, we have asymptote of 0. So now, when you draw your xy coordinate plane, you have your vertical asymptote, and then you have your horizontal asymptote. And those act as guides to draw the function. Now, what can you draw? Well, you can draw, remember that functions can cross horizontal asymptotes, but they cannot cross verticals, right? So we can draw this, but the question is, right, we can draw these 4 lines, but we know that we can't keep both of these because it would not be a function, right? It fails vertical line test. If you put both of them, then it fails vertical line test and it's not a function. So we have to get rid of one of these 2 curves. So which one do we get rid of, right? It's a very simple way to test this because you can pick a point, any point on this side of the graph. So if you pick, let's say, -1, x equals -1, y would be 1 divided by -1, also -1, and you see that -1, -1 is a point which would eliminate the line on top. Because you can either have the line on top or the line on the bottom. You can't have both of them. So you can just quickly test any point. Test any point on the x-axis here. Any. And it will give you a value for y that it's either above or below. And then we do the same thing on the other side. For x equals 1, right? Y is 1 over 1, which is 1. So that's a point right there, which eliminates the bottom line. And this is how we know, right, the graph that we memorized, that's why it's that way, right? Now, for a little bit more complicated case, remember the example I had before? F of x, we had x squared plus 6x plus 5, I believe, divided by x squared minus 25. So this example was the one that I did earlier for vertical asymptotes. So what are my specs, right? The vertical asymptote is at x equals, what was it? X equals 5. And we know that at -5 we did not have the vertical asymptote because that one term cancels when we factor. Let's write it. F of x is equal to x plus 5x plus 1 divided by x plus 5x minus 5 when you factor it. And now these cancel. So we are only looking at x plus 1 over x minus 5. So we only have a vertical asymptote at x equals 5. And the horizontal asymptote is at y equals 1. Because we have the same exponents and the leading coefficients are 1 and 1. So 1 divided by 1 is equal to 1. So a equals 1, b equals 1, 1 divided by 1 equals 1. So that was the case 2 we had. And now to graph, all I need to do is to follow the guidelines. I have the vertical asymptote at 5. 1, 2, 3, 4, 5. There we go. And then I have horizontal asymptote at 1. So in this case, I can draw a function like this. I can draw like that. I can draw like this, and I can draw. See? So these are all 4 lines that we can draw so that they follow the asymptote. All right, so now, what lines do I eliminate? Again, just pick any value and compute. So let's pick value of, I don't know, you can pick any value. Now, obviously, easiest value to the left of the red line would be 0. So how much is f of 0? F of 0 is 0 plus 1 divided by x minus 5. It's negative 1/5. 0 minus 5. So we are eliminating the top line. Right? We are eliminating the top line. And the bottom line looks like it's going to go through negative 1/5. So we should do more of a curve there. Something like this. It has to go through negative. Now, on the other side, calculate, so since this value is at 5, you can calculate f of 6. And that's going to be 6 plus 1 over 6 minus 5. That's 7 over 1, which is 7. So that's bigger than 1, therefore, that's what it looks like. So this is going to bend to follow asymptote forever. It bends on top as well to follow it up forever. And it bends so it follows the blue. All right. So now I just need to catch up with the chat and see what is the question, because I'm not sure which question which problem are the questions for. There is no reference. I don't have vertical asymptotes of x equals 1 anywhere. We do have a vertical asymptote at 5. We calculated that long time ago. Right here, vertical asymptote is 5. I did the same problem. So I'm not sure what these questions are connected to. So I took this problem and I wrote it down the same way here. And then when you factor, vertical asymptotes are only in denominator, not in the numerator, denominator. And denominator had two of these terms, and one of them canceled, which is the one that takes out -5. So the only value in denominator that makes the asymptote is x equals 5. That's the only place where you get your vertical asymptote. Vertical asymptotes are x equals, because those are vertical lines, right? Vertical line is x equals a number. So vertical line. So in this particular problem, now there are going to be other problems where you might have two asymptotes if they don't cancel. So that's a big problem that we can't really detect unless we do the factoring and canceling properly. So let's say you have f of x is equal to x plus 3 divided by x squared minus, let's say, 7x minus 8. All right. So if you are to factor this problem, you would get x plus 3, and you would have x minus 8, x plus 1. Now in this case, both will survive. Therefore, when we set them to 0, we get x equals 8 and x equals -1. So here are your vertical asymptotes. So in this case, right, you're only setting denominator to 0, and you only look for the term which didn't cancel. So in this case, none of the terms canceled, and because none of the terms canceled, we don't have any cancellations to make, right? So that we keep all of the asymptotes. So for horizontal asymptote, we have P less than Q, which is our case 3. So horizontal asymptote at y equals 0. Horizontal asymptote at y equals 0. So now we have our x values. So here is the asymptote at -1. Here is the asymptote at 8. And we also have a horizontal asymptote at 0. In this case, again, it's x-axis. X equals -1 and x equals 8. So these are my asymptotes. And now we go and we figure out what to keep and what to throw away. So over here, oops, we're going to have one of these. Right, it follows the asymptote up and down. So we have to throw one away. You cannot keep both because it fails the function, right? So we have to erase either the top line or the bottom line. Well, just pick any x value and compute in your problem. So how much is f of -2? Okay, we have -2 plus 3 divided by -2 squared minus 7 times -2 minus 8. So that is 1 divided by 4 plus 14 minus 8. That's 1 over 10. Well, that's positive. So above x-axis. So we delete the line that is, we delete the line that is below x-axis because that line has negative y values and all we have is a positive y value when we did the calculation. We do the same thing on the other side over here, where we have again two different lines, and we can use f of 9 for instance, because look, this x value here is 8, right? The x value is 8. If x value is 8, then we can use 9, 10, you can use 1 million if you want to. Use any x value that is to the right of 8. So let's figure out, we have 9 plus 3 divided by 9 squared minus 7 times 9 minus 8. This is going to be 12 divided by 81 minus sorry minus 63 minus 8, right? So we don't even have to compute. This is less than right, this is 71, so it's 12 over 10. So sorry, this is well, let's write it 12 over 10, right? We can. So if it's 12 over 10, that's again bigger than 0, so it's also above x-axis. So we delete the lower line. So this is how you get these things, right? In calculus, you will be able to compute derivatives, and you will be able to compute. So you will redo this lecture in calculus. All of what we are learning in pre-calc is relearned in calculus and used in calculus. Every single lecture, especially 1.6, 1.7, 1.8. There is a reason why this is called a pre-calculus course. Everything that you forget, anything you forget from this course, will haunt you in Calc 1. So if you are learning this course for a grade, you are not going to have any fun or success in calculus. All right, so we still have to fill in the middle, and then we're done. Now for the middle, we can have some kind of U shape like this or a U shape like this, but there is way more than that. We could also have this or this. So now we have, so it's either going to be a U shape or a U shape going down, or it's going to be one of these shapes because we can cut through. It's allowed to cut through horizontal asymptote. Again, you will understand this in calculus, because in calculus we will define horizontal asymptote to something is called limit as x goes to infinity of f of x and blah blah blah. This piece over here will tell you something that asymptotes can have to be obeyed at infinities for horizontal and so on. So there will be much more to learn about all of this when you reach calculus 1. Right now, I am asking you to remember that the middle can be a U shape going up, a U shape going down, or one of these that actually cuts through. Now, we first try and figure out what shape we have. So is it going to be, for the mid part, is it going to be a U shape or one of these cross shapes? And we can detect that very easily. Look for X-intercept. This one creates X-intercept, and this one no X-intercept. So that's how we know what's what. So when we have So now we look for X-intercept. Look for X-intercept by setting y equal to 0. So that's our whole problem of x plus 3, y equals x plus 3 divided by x squared minus 7x minus 8 equal to 0. When you cross multiply, you just get x plus 3 equal to 0, from where you get x equals negative 3. We got to intercept. Did I write all of this correctly? Yeah. Okay. So we have an intercept at negative 3, but we do not have intercept here. So no x-intercept in this area, which means we cannot have the line that crosses through. That is something that we all need to eventually figure out. So now I know it's going to be a U-shape, and that U-shape, it's either the U-shape going up or U-shape going down. And for that I can just compute, let's say we can compute at 0, because it will either give you a positive value up there or a negative value over here as a y, right? So now we calculate f of 0. That's 0 plus 3 divided by 0 minus 7 times 0 minus 8. That's 3 divided by negative 8. And that's negative. So we should keep the bottom U-shape and erase the top U-shape. So I hope that this is the graph. And the best way to confirm this is you guys just go on go on let's say a website called Desmos, and if you properly enter the values in Desmos, you will be able to graph this and see all of the features. So let me see if I can get the Desmos real quick over here. Desmos. There we go. Beautiful graph. Start graphing. There we go. All right, so what is our problem? Our problem was, now you have to be very careful to type this exactly. You have to use parentheses for the numerator and parentheses for denominator. Otherwise, it's not going to be correct. So open parenthesis, then we have x plus 3, if I remember. Close parenthesis, then you divide that by another parenthesis. I'm just going to keep everything in there. We have x, and that's going to be we need to square this. So squared, x squared, there we go. Now we have to escape this, and then minus 7 x, and then minus 8, and close the parenthesis. So I hope this is we get the graph. So this should be what we have, right? Yep. It's not the same exact shape, but you see it's a little bit crooked, but that's okay. I mean, this is sketching. In calculus you will learn more. Now please observe that there is a -1 asymptote, right, on x, -1. So there is a -1 asymptote. There is also asymptote at 8. You see how the lines follow the line 8. And it's never crossing. It's always just approaching, it never crosses. And you can also see that the x-axis, which is y equals 0 for horizontal asymptote. Now be careful. Horizontal asymptote can be crossed, right? You can cross horizontal asymptote. So we just have to be a little bit careful in that case. You know what? Let's look up an example of when it crosses the asymptote. What should we do? How about f of x equals x over x squared minus, let's say, 16. That should be good enough for us. So now in this case, all right. So in this case, we're going to have vertical asymptotes at x squared minus 16 equal to 0. We factor this into x minus 4, x plus 4. And then when you set each one of these equal to 0, you get x equals to 4 and x equals to minus 4. So these are two vertical asymptotes. None of them canceled, right? X minus 4 and x plus 4, they're not the same as x, so they don't cancel, and we keep both asymptotes. Now for horizontal asymptote, I have p equals 1, q equals 2, right? So p less than 1, so y equals 0, that's a case 3. You have to memorize those 3 cases. So I'm not making this stuff up, right? I just know what they are, and when the stuff comes up, I just use it. So that's what I have. And then I am going to just graph now, right? That's it. I'm done with this stuff. So let's go and see what the graph would look like. We have our x and y axis. I have my 2 red asymptotes. So I don't know why I made this wide, but whatever. 1, 2, 3, 4. So here is my first asymptote. That's at x equals 4. And then 1, 2, 3, negative 4 is the other one over here. Negative 4. And then I have options again, right? So what are my options? My options to the left are these two. You know what? Let me first find X-Intercept, just to make sure that life is right. So X-Intercept, we set x over x squared minus 16. We set that equal to 0. When you cross multiply, you get x equal to 0. So I know that there is only one x-intercept, and that one x-intercept is at the origin. Good. Now, function has to go through it. Now, because there are no other x-intercepts, this line must do either this or this. You can't have both, right? Or. So we have to get rid of one of these two. Now, the easiest and fastest way to figure out which one we keep, which one we get rid of, we compute any number from the region we are observing. I'll do -5, right? -5 is right here, and I'll use that. If I get a positive number, then I keep the upper line. If I get a negative number, then I keep the lower line because it's in a negative area. So I have -5 divided by -5 squared minus 16. That's -5 divided by 25 minus 16, and that's negative 5 divided by 9, which is negative. So I get to get rid of the top line. I got a negative number, right? The y value is negative, and the negative y's are below x-axis. So I am getting this value here, right? So that's why I'm keeping the bottom line. Another easy one is all the way to the right. Do I keep the top or the bottom? Well, we just calculate f of 5. That's 5 over 5 squared minus 16, which is 5 over 25 minus 16, which is 5 over 9. That's positive. That means I am keeping the upper line in this case. All right. Now we get to the middle. Middle is always the one that makes a lot of noise, right? And having the X-intercept, right, kind of helps, but it doesn't. You still have to do all the work. Because, you see, remember how when you had the multiplicity 2 root, it went down and bounced off of it and went up? So there you go, X-intercept still, right? So we can have a U shape going up, a U shape going down, right? We can have those. But we can also have a squiggle like this, or we can have a squiggle like this. So there are 4 different possibilities in this case, right? And the question is, well, which one is it? This is where we compute 2 values. One is going to be computed here, and the one is going to be computed there. And they will also give you positive or negative numbers. If you get a positive number, then you keep the positive side, you keep these 2 lines, right? And so on. So now, what I'm going to do is I'm going to calculate f of negative 3 and f of 3. So f of negative 3 and f of 3. So negative 3 over negative 3 squared minus 16 is negative 3 over 9 minus 16, which is negative 3 divided by negative 7, which is 3 over 7, which is a positive value. It's a positive value. That eliminates 2 negative lines. See that? Positive value. We got this number here. So, when I deleted the bottom ones, it eliminated the blue line and eliminated the black line. There was the downward U. Now the question is, do I get to keep the black or the orange? And that's going to be determined with f of 3. Because when I do this one, we'll get 3 over 9 minus 16. That's 3 over negative 7, which is less than 0, because it's a negative fraction, which means I have to delete the positive one, so I'm deleting the black, and there it is. So that's the middle shape. I had all 4 shapes there, the upper U, the lower U, and both of these, and by process of elimination, we came up with a shape in the middle. It takes a lot of practice to do these things. But the coolest thing is we're always checking with the values that are quote unquote, right, close to the asymptote. Because the function should curve and follow that asymptote. Function should curve and follow the asymptote. And let's see. So now we had, 4 examples of these? Maybe 5? 2, 3, 4, 5. Okay. Now, before you faint, there is one more type of asymptote. We did not talk about the third kind of asymptote called the slant asymptote. And that one occurs when there is no horizontal asymptote in one case only one case of slant asymptote, and you can get it. So now you can get it when the degree is by 1 higher. Now that will make more sense when we write it down. So here is the third type of the asymptote called slant asymptote. Some people also call it oblique asymptote. Oblique asymptote is of the form y equal mx plus b. And you're going to love it, right? It's obtained by long division. So slant asymptote is a linear line y equal mx plus b when p equals q plus 1, and we get it by long division. Remember how you learned long division in 2.4? Now we get to use it for the slant asymptote. And spoiler, calculus 1 and right beyond. So what is the case for the slant asymptote? Slant asymptote only occurs when the degree in the numerator is by 1 higher than the degree in the denominator. So this is the situation when you have slant asymptote. P is 3, Q is 2. P bigger than Q means no horizontal asymptote. No horizontal asymptote. But because they are just by 1 apart, because they're by 1 apart, we do have slant asymptote. We do have slant asymptote. And as I said, you know that you're supposed to do long division of polynomials to get it. So now we use 2.4, long division of polynomials. If you don't know it, well, you have to go back to 2.4. And we are going to take a look at, in this case, we're going to go and take a look at this. So let's see. We have x squared plus 0x minus 1. I'm going to put this one in as a placeholder because it's missing. Divided into 3x cubed plus 0x squared plus 6x minus 1. X squared goes into 3x cubed 3x times. Multiply it back. We get 3x cubed plus 0x squared. And when we subtract, we still have 0x squared plus 6x minus 1. Well, 3x squared goes into 0x squared 0 times, so we're done. The slant asymptote we don't care about the remainder, we don't care about any of those things. We just want to calculate y equal mx plus b. So y equals 3x. That's it. That's our slant asymptote. Now, our problem also had the vertical asymptote because it was x squared minus 1 equal to 0. Remember, that was the denominator? And we set denominator equal to 0. So that one will factor into x minus 1, x plus 1. And we have x minus 1 equal to 0, which gives us vertical at 1. And x plus 1 equal to 0, which gives us vertical at negative 1. So I have two vertical asymptotes. I have a slant asymptote, and we said no. You cannot have slant and horizontal at the same time. It's impossible. Slant asymptote occurs in the case 1 when you have no horizontal asymptote. Right? Case 1 has the degree in the numerator larger, and slant asymptote requires numerator to be larger by 1. Therefore, right, you can't have them at the same time. So now I can graph this problem. Let's see. If I graph my... Oh, I color-coded this differently. Okay, so let's go now with the blue on these. And the slant asymptote at 3, slope is 3 over 1, so it goes like this. I need to make this much wider. This is terrible. Get rid of everything. Actually, why I'm doing that when I can do this like a pro? Like a pro I am, right? Go back. So I'm going to pick 2 units to be 1, and I'm going to hit my vertical asymptotes. You know, the first rule of engineering, draw big. If you are not doing that, then you will never have a chance of being an engineer. All right, cool. So we have these guys. And now I need to draw the slant asymptote y equals 3x. Well, y equals 3x has a y-intercept of 0. So it's going to go through the origin. Then we're going 3 units up, 1 unit over. I hope you remember that the slope of 3 is 3 over 1. It's rise over run. So rise 3, run 1. So 1, 2, 3, 1. 1, 2, 3, 1. There we go. 1, 2, 3, negative, right? 1, 2, 3, negative. There we go. So now we draw our slant asymptote through these points. This is gonna be terrible to draw, but let's hope it works out. Okay. First order of business is to calculate our X-intercept. So we're going to take our problem, 3x cubed plus 6x minus 1, 3x cubed and 6x plus 6x minus 1, and set that equal to 0. Now, being that this is a problem that I just pulled out of, thin air, I wasn't thinking about something nicely, easily factorable. Whatever, I'm going to cheat and look for the roots of this in the software and see if we actually get any values that we need. So, solve 3x cubed plus 6x minus 1 equal to 0. What does it say? A approximate forms. What do I have? Ooh, I have only one real root and two complex roots. So x approximately being 0.16 plus two complex roots. If you paid attention last class, you would know that the cubic must have three roots. Now, we don't care about complex roots. We can't graph those in here. So we only have one, 0.16. So that one is here somewhere. All right, cool. So let's see what this function looks like. Now, here is the problem here, right? See, this red line, right, will go forever down, and the blue line will go forever down. Now, please focus here. Focus, focus, focus. We have to follow the blue line, and then we have to follow the red line. So one possibility is this, and the other possibility is this. That's it. Those are our two options, to follow blue and red at the same time. Now, I hope that you see that we are going to eliminate the upper one because it's creating a non-existent X-intercept, right? So we eliminate the top one and we keep the bottom one as the good one. We're going to do the same thing on the other side. The blue and the red lines will go forever. And we're going to have this, and we're going to have this. Again, this one would create a non-existing X-intercept. We know there's only one X-intercept that we can use. So we know that there is no X-intercept that it's 1 point something. So we have to eliminate that line. You cannot have it. And that's why this is the only thing that survives. This shape on top. And now we have to deal with the middle. Now, bad things that these are 1 and -1, right? So we have to pick up values like 0.9 and -0.9 and compute with them. I mean, we'll live, but it's just annoyance. So we have to compute f of 0.9 to see if we are following like that, or if we are going to follow from the top and then cut through this one to go through. Both situations can occur. Horizontal and slant asymptotes are in the same family of asymptotes that can be crossed, where the vertical asymptote is the one that can never be crossed. So I have to compute f of 0.9, which is going to be 3 times 0.9 cubed plus 6 times 0.9 minus 1 divided by 0.9 squared minus 1. So this is going to give us a negative number. Now, I just know that because 0.9 cubed times 3, that's going to be a large positive, and then it's going to even get more positive, and subtracting 1 from it, it's not going to make it enough, right? So it's the top is positive. The bottom, 0.9 squared is 0.81, and when you subtract 1, the bottom becomes negative. We don't need to know the value. We don't care about the value. I just want to know that it's below, so I know that my function follows from here, and it's going to hit my X-intercept. So I know that's happening there. Now, how about my 0.9 on a negative side? So that's going to be 3 times negative 0.9 cubed plus 6 times negative 0.9 minus 1 divided by negative 0.9 squared minus 1. Now that's positive. You will say, what? How? How do you know without calculating? Well, first off, always remember who you're talking to. Right? The second one is negative number cubed is going to be negative times 3. That's negative. This is positive times negative is negative, and then minus 1. So we just have negative numbers on top. So the numerator is whole negative. Denominator, when you square negative number, you still get positive, but you get positive 0.81, right? Positive 0.81 minus 1, so you get negative divided by negative, so it's positive. There you go. So it cuts through the axis and follows the other side going up. Immediately what you should do next is pull up Desmos, graph the function, and see for yourself that this is what it is. Now that concludes the lesson on 2.6, and it also concludes the chapter. Now before we go further, I need to address a couple of uses for this. We can take a look at another problem, and then next time on Wednesday we can do more problems for chapter 2, and we are talking about having the exam next week. So if you want to have it Monday or you want to have it Wednesday, then we can have the I will post stuff in Canvas, right, as announcement. I will open the homework, obviously, and all of that stuff, so you guys, go and discuss things and check things out and so on. Okay. So these rational functions are useful for us to understand the world around us. I'm just going to give you a very one of my favorite examples, a very interesting example, which is what happens when you divide by 0. What you would say in real life, because this is over here a fake life, right? I want you to think about the regular outlet and what happens when you short it. Mini explosion happens, right? Now, why is that so? So here is the example of rational function. What's happening? First of all, we have something called Ohm's law, where current is equal to voltage divided by resistance. When you plug in your cell phone charger, it says 2.1 amps. That's current, 2.1 amps. New chargers, some of the new chargers even go up to 3 amps. And the voltage, that the voltage is 110, right, in the wall, 110 volts. It's more like 118, 120, but it drops down to 110 when you plug something in. All of the devices that you have, including TV, cell phone chargers, your fridge in the house, they all have resistance. And when you plug them in, then the resistance divides into voltage, and you get the number of amps, and you can get the power if you want to, right, later, as the current times voltage and so on, right? So there's a lot of physics that you can learn if you want to, right? What's interesting is that short circuit is R equals 0. So here is your function at work. I equals 110 divided by, 110 volts divided by 0. That is trying to make vertical asymptote. Vertical asymptote shoots to infinity. If the current is trying to be infinity, then the temperature is trying to be infinity, because there is a formula in physics that connects the current in the wire with the temperature of the wire. The more current you have in the wire, the more motion of electrons is happening, because current is flow of electrons, of charges, right? Flow of electrons. And the more they move, the more they heat things, because that's what heat is, kinetic motion, right? You know, you warm up to move around, right? Move around to warm up. So, or you friction with hands, right? You move hands, palms of your hands, right? Rub them one into another very quickly. You create heat because there is motion. So a lot of rapid motion creates a lot of temperature, and that's how explosion happens, because the temperature is trying to reach infinity in practically zero time. And that's what the explosion actually is, mathematically speaking. So all of the bad designs, you know, when you have exploding batteries and all of these kind of things, we had them in laptops and cell phones and so on. Those are all oversights of the design of engineers here and there, where they had division by zero. So when I say in class, oh, explosion, I'm actually not joking. This is what it means, right? And you can see it in this example here. So I'm giving you a basic physics formula. You know that your chargers could be, 2 amps, and the volts in the wall are 110 and so on. So if your resistance is 0, then you are dividing 110 by 0. Now remember the graph? See, this graph of I equals V over R is technically 110 divided by R, and if your R is X, right? So that graph is this, where this is your resistance and this is your current. Now, do you see what happens as you are going close to 0? Right? If your resistance is here, then no problem, right? You have your output in current, 2 amps, let's say. If your resistance is here, then you have maybe 3 amps. If your resistance is here, maybe you have 4 amps. But if your resistance is 0, you are riding a vertical asymptote to a positive infinity up there. And that's how the current is trying to be infinite, and because current and temperature are proportional, right? Then the temperature is trying to be infinite in the small period of time, and you get the little explosion. When you short the circuit, you get a little explosion. That is your division by 0 in this case. And no, it's not a Schrodinger's cat. It's a different thing, but I appreciate the reference. It's not Schrodinger's cat, but we can talk about Schrodinger's cat as well. It's a really cool idea, but it's not related in this case. You guys are so funny. Anyway, so that's one of the applications where you would see these things at work. Now, obviously, you are going to have a whole bunch of word problems that you can enjoy and so on. Since we are out of the time this time, on Wednesday, I am going to graph maybe 2 or 3 of these to review. We'll do something with the long division again to review that one a little bit, and we'll do a couple of more word problems to wrap the chapter up. Your job, in addition to homework, is to also think about exam 2. Exam 2 is supposed to contain chapter 2. We only have 6 sections, which includes 2.1 complex numbers. So think about exam 2, sections 2.1 through 2.6. That exam needs to happen, obviously, on MyMATLAB, so hopefully everything will be, going according to plan, unless they say, yep, our servers. I know that many of you have, I said this at the beginning, right? A lot of you have access issues. That has been documented on their website, and since everyone is working remotely, they are working as hard and as fast as they can to try to fix the issues, so you guys can log on and practice your stuff. In case that my MATLAB servers explode or something, then I will be posting problem sets in Canvas, and you will be downloading the files off of there and work on those. There is just so much that we can do in a situation we're in. You probably already heard the news, so we're out for this semester. Summer 1 is also online, and they're hoping to have Summer 2 part in person and part online, depending, So, yeah. So that's what we're doing. We will talk more about the details of the exams when we get there. We are already 15 minutes over time here. So we all need to be creative and figure out what to do with a whole bunch of stuff. I still think that it's better to have anything than to have nothing. But, those of you graduating in May can still graduate. They're looking into postponing the graduation and waiving your fees, I believe, something like that. So please check your emails from the college president. He's emailing everyone. And regarding our class, make sure you are reading the announcements, because this is the only way for me to communicate with you, through announcements. I am literally receiving hundreds of emails a day. I have more than 150 students in 5 courses. And when I combine the department and colleague emails with administration emails, with Nigerian emails, and then student emails, guys, I get over 100 emails a day. I can't catch up. I'm thinking of just like purging the whole thing. I put the president's emails and the department chair emails on the list. Department chairs are getting even more, because every student who doesn't hear from goes, department chair doesn't even open an email, I guess, anymore, because it's impossible. I mean, what I need you to do is to go on announcements, read the announcements, and reply in the announcements. We can have discussion. This will be the professor-student discussion, right? In announcements, where we are all talking about the class, and we'll keep the online course, what we're doing here, we'll keep that so we can do the lectures and review. So we might have, I hope we are going to have exam next week. I hope. I don't know, we'll see, but I hope. And for that exam, we are going to have a review in this way, where I hope that you guys, I hope you guys are going to post your questions, and I will also ask you to send your questions in the email when I start teaching. I am going to open the email, and then whatever I get at that point, right, while I'm on live, I will be able to open the file right away, because as I said, everything you send, right, it gets buried by another 50 to 100 emails. They're just keep coming in. It's very difficult for me to sort through the whole mess and see what's important, what's not important. It would be taking me, 12 hours a day just to sort through that mess. It's just way too much. So I need you to go on Canvas, go to Announcements tab, keep reading, keep monitoring that tab. Anything that I have that it's important for the class will be posted there. And you have the ability to reply all, right? It's a discussion underneath. And if you have something that it's really, private and so on, I'll need you to email me, but then we'll have to, I have to figure out how to sort through the massive emails and all of these kind of things. So that's it for today. When we come back on Wednesday, we'll have some kind of combination of instruction and a review, and we'll also set the date. So on Wednesday, we're setting up the date for exam 2. Exam 2 will cover only 6 sections of chapter 2, and possibly the word problems, which is well, let me maybe put over here plus 1.10 word problems. So that will be all for exam 2. I need to make sure that you are keeping up with those problems. And then exam 3 will only be chapter 3. Then we will have to finish some of the chapter 7, and then we have a final, guys. We only have about 6 weeks, I think, left or something like that. So we really have to, pick up the pace and make sure that we are not behind, so we can end the course. So I'll see you all in 2 days, 6 p.m. on YouTube. Bye.